studying for my ANP2 fourth exam, and so I keep coming across ANP versus ADH versus aldosterone. So I was trying to figure out what are these, and what do they do, and what are their differences. So first, ANP is Atrial, Natriutetic, Peptide, or you can say hormone. So it could be ANH or ANP. And then ADH is Antidiuretic, hormone, and then there's aldosterone. So I just want to go over what these are and compare and contrast them a little bit. So first, ANP is atrial natriuretic hormone or peptide, and this is released by the heart. So atrial, as it sounds, you have we'll make this a little bit bigger, 4 chambers of the heart, and you have the right atrium. And so when we say the right atrium, the atrial, we're talking about the right atrium. And so it's because of baroreceptors and stretch receptors in the right atrium can sense an increase in blood pressure, which is going to stretch the right atrium. And so that's how the body knows to release this hormone, is an increase in blood pressure. The mechanism for this is that it increases excretion of sodium, and therefore we increase our excretion of water, because we know wherever sodium goes, water goes with it. And so this will result in the decrease of blood pressure. Next, we're going to talk about antidiuretic hormone. It has some other names, so ADH or vasopressin. It acts on the kidneys. It increases water reabsorption in the collecting ducts, and it binds to the V2 receptors there. It is released by the hypothalamus, and it's from the thirst reflex. So when you start to feel thirsty and a little bit dehydrated, you start releasing this. You start releasing ADH, so you retain more water. And the reason you have this thirst reflux is because the osmoreceptors in the hypothalamus start to shrink, and so they know to release this because we're shrinking because we don't have enough water. In the same way, the other ones, as the osmoreceptors expand, it will tell you that you have enough water, and so we can continue to make antidiuretic hormone and release it. So here is what I got: the glomerulus, and I got the posterior, or just the PCT, and the distal. I have I didn't mean posterior, I mean proximal convoluted tubule, and the distal convoluted tubule, and the nephron loop, or the loop of Henle. So here I have made it so you can see that the cortex is above this gray line and the medulla is below this gray line. That's kind of important because in the medulla is when here this descending loop of the nephron is when we excrete most of our when we reabsorb most of our sodium, and so it makes the medulla pretty salty, and so that'll come into play in a little bit. And so one more important thing I want to point out is that this vasa recta versus these peritubular capillaries. So peritubular capillaries are important for nutrient and water reabsorption, and they are in the cortex of the kidney. And then in the medulla, that's when you have this vasa recta, and that is for water balance. And so 65% of reabsorption happens here in the proximal convoluted tubule, and only like, I think it's another 15% here, 15% here, and I think 5% here in the collecting duct. So that's just to give you kind of an example of that. The most of what is reabsorbed is going to be reabsorbed in the proximal convoluted tubule, and so that's why the peritubular capillaries are usually reabsorbing water and nutrients, whereas the vasa recta are more for water balance, so kind of the fine tuning of what we need to reabsorb. And so how this works is that we're going to see part of the collecting duct here. It's the and so we know the collecting duct is where we get our filtrate has been filtered, and so now it's urine. And how antidiuretic hormone works is it acts on the collecting duct. And so here I've kind of zoomed in on a part of this collecting duct. So antidiuretic hormone comes here and it acts on these principal cells in the collecting ducts, and it opens up aquaporins, which are just water channels. And since the medulla is salty, right, because all this salt is reabsorbed to the proximal, or all this salt is in the descending loop of the nephron, now we've made the medulla salty. So all this water wants to come out into the medulla once we open up these aquaporin channels. Without ADH, these aquaporins are not open. So you wouldn't typically reabsorb water. In the collecting duct, it's usually impermeable to water. But when ADH acts on it, that's when these aquaporins open. So water is drawn out because wherever sodium is, water wants to be. So that's why the water is drawn out through these aquaporins. And then water is reabsorbed by these vasa recta. And so that's just kind of important for what's going on here. And then now we're going to talk a little bit about aldosterone. Aldosterone is my favorite hormone in all this. Okay, so aldosterone is secreted by the renal cortex. Aldosterone is one of the last players in the renin-angiotensin mechanism. And it is going to help you increase reabsorption of sodium in the distal convoluted tubule or the collecting duct, and then water follows that sodium. So we're going to increase blood volume by reabsorbing that water. Same thing with ADH. We're reabsorbing water, we're increasing blood pressure, we're increasing blood volume. So how this is then going to work is we have so we have these, we have here, like, we have the glomerulus, and which, fun fact, means ball of yarn, and we have the afferent and the efferent. And how I remember these is that the afferent arteriole goes into the glomerulus, and the efferent leaves the glomerulus because A comes before E in the alphabet. Now, here we have a few different cells. So we have the macula densa here in purple, and then we have the juxtaglomerular cells. So the juxtaglomerular cells are what are going to release renin when blood pressure gets low. So these juxtaglomerular cells are what release renin. So these guys on the sides of the afferent arteriole are going to be what releases renin. And you can sense when this afferent arteriole, when there's a low blood pressure, and so that's when renin is going to be released. So this cycle is angiotensinogen is made by the liver, and that just hangs out in the blood. And then when renin is released from the afferent, or from those juxtaglomerular cells, that's when, we'll put it here, the juxtaglomerular cells, then these renin acts on that, and you get angiotensin 1. Also important note, ogen means precursor, or like it proceeds. So ogen, precursor to, so angiotensinogen is a precursor to angiotensin. So angiotensin 1 doesn't do anything until it makes its way to the lungs, where you have angiotensin converting enzyme. We'll put that here. So let's see here. Enzyme. There we go. Sorry guys, took a minute to figure out how to spell that. So angiotensin converting enzyme is then going to make that angiotensin 1 into angiotensin 2. So angiotensin 2 does two things. So it acts on the renal cortex. We're going to release our friend aldosterone. And when angiotensin 2 is also a systemic vasoconstrictor. So then it's going to, so here we said blood pressure was low going through the afferent arterioles. So then we're going to make our afferent arterioles constrict. And that's how we're going to know that our blood pressure is rising, because of everything that angiotensin 2 is doing. And so, interestingly, the macula densa cells are what helps to signal the juxtaglomerular cells that, hey, it's time to release some renin. So when sodium is low in the blood, it's going to release prostaglandins, and that's going to stimulate the release of renin from the juxtaglomerular cells. When there is salt in the blood and it's a high enough concentration, then the secretion of prostaglandins is stopped, and we stop making that renin. So then, real quick, one more time, we have this cycle. We have the macula densa cells, or we have a low blood pressure in the afferent arterioles, right? So either macula densa cells are secreting prostaglandins, or low pressure in afferent arteriole. We are then going to release renin from the juxtaglomerular cells. Angiotensinogen is made in the liver. It's been released in the blood, waiting on renin. Renin comes along. Angiotensinogen is then converted into angiotensin 1. Angiotensin 1 makes its way all around the body, and then eventually in the lungs it finds the ACE receptors, or the angiotensin converting enzyme. And so then it's going to be converted into angiotensin 2. This then can act on the renal cortex, and you can release aldosterone, or it can cause, and it can also cause vasoconstriction. So now we're going to compare these. So there we go. And we're going to say the trigger for, let's see what color we want to do here. We'll do, how about this blue? So the trigger for ADH was dehydration. The trigger for this was going to be a high blood pressure. And the trigger for aldosterone was going to be angiotensin 2. So their mechanism, this is going to, you're going to reabsorb water in the collecting duct. Just put for here we were going to its mechanism of the natriuretic acid was gonna oppose aldosterone and stop stop in a reabsorption. And this was going to increase Sorry, guys, sometimes spelling's hard. So then now let's think about the effect on blood pressure. So ADH was released because we're feeling dehydrated. And so that means your blood volume or your blood pressure is low. So then we're going to, I'll just put it down here. Right, you're dehydrated, blood volume, and low blood pressure. So then if we are reabsorbing water, that means then we're going to add H2O. So then that means that our blood pressure and our blood volume are going to go up. So the effects on blood pressure, it's going to increase blood pressure. Next, let's look here at atrial natriutetic peptide. It was when blood pressure was too high. Or you could say your blood volume was too high. So then it's going to say no more sodium, and then you're going to pee out all of this water. So then then this is going to be that you're going to decrease the blood volume or decrease blood pressure. So the overall effect this has is we're going to decrease blood pressure. Now for aldosterone, right, this is going to encourage reabsorption of sodium, and then we know where sodium goes, water goes, so this is going to increase blood pressure, and this makes a little bit of sense if we think back on it. Angiotensin 2 is going to be because angiotensin 1, which was released because renin was released, and renin was released because of a low blood pressure, or we had a low concentration of salt in the blood. So I hope this was helpful. Let me know what you guys think, and I appreciate it. Thank you.